Brian, what is calculus? I have no clue.
Me neither, Stewie. It's just math.
A stag full of boys. Calculus is the branch of mathematics that studies how things change. It provides a framework for modeling systems in which change occurs and offers powerful tools for analyzing those changes. The two main areas of calculus are differential calculus and integral calculus. Differential calculus is concerned with the concept of a derivative, which measures how a function changes at any given point. Integral calculus deals with the concept of integration, which is essentially the reverse process of differentiation and is used to calculate areas, volumes, and accumulated quantities.
Peter, I'm trying to learn more about calculus. Tell me about functions.
Of course, Stewie. Functions are a rule in calculus that assigns an input exactly one output value. They are integral in calculus because they model relationships between varying quantities.
Wait, so functions can be written like f at x equals something else?
Exactly, Stewie. But you should know the different types: linear, polynomial, trigonometric, and exponential.
Hey, Peter, how do limits play into functions in calculus?
Stewie, limits are fundamental in calculus. They help define the behavior of a function as it reaches a certain value.
That's great, Peter, but can you give an example?
Of course, Stewie. Let's consider a simple function in calculus. F at x equals x squared. The function f at x equals x squared is a quadratic function, which means that the output value of the function is the input value squared. Now, let's discuss the limits of this function. For any finite value c, the limit of fx as x approaches c is simply fmx. This means that as x gets closer and closer to c, the value of x squared gets closer and closer to c squared.
Thanks, Peter. Hey, Peter, what do you know about continuous functions in calculus?
Everything, Stewie. For a function to be continuous at a point, it must meet three conditions. The function value at that point must be defined. The limit of the function as x approaches that point must exist, and the limit must be equal to the function value at that point.
But what happens if any of these conditions fail?
A discontinuity occurs. These can be classified as removable, jump, or infinite.
Hey, Peter, I keep hearing Stewie talk about derivatives. What's that?
Derivatives are a measure of the rate of which a function changes, Brian. They can generally be defined as f at x equals the limit h approaching 0 of f at x plus h minus f at x over h.
But what about for f at x squared?
Here we can see the function with x squared plugged in. From there, we can expand and simplify the numerator to get this. Then we need to factor out h. Then we evaluate the limit as h approaches 0 to get the derivative x squared. As h approaches 0, f prime of x equals 2x.
Peter, do you have problems for me to review Chapter 1?
Of course. Stewie, Chapter 1 review. Problem 1, find the limit as x approaches 3 for the problem x squared minus 9 over x minus 3. To solve, you're going to expand x squared minus 9 to x minus 3 and x plus 3. Next, you divide the x minus 3 by x minus 3. You then get x plus 3. Then you evaluate the limit as x approaches 3 to get 3 plus 3. So, the answer to this problem is 6. Problem 2. Use the definition of a derivative to find the derivative of the equation f of x equals x squared plus 2x. To solve, plug the equation into our derivative formula. Then, expand the equation and simplify. Once you do that, divide by h to get 2x plus h plus 2. Then take the limit as h approaches 0 to get 2x plus 2. So f prime of x equals 2x plus 2. Follow calculus, Peter, for more.